Good afternoon, and welcome to track number 5, which is phased development, something I think that we should all take an interest in. I think it's a very timely and topical subject, especially with the clients that we serve and their expectations and demands. So this should be a very good session for everyone, and I hope you get a lot out of it. My name is William Maybush. I'm with Turner Construction.
And my name is Hyun-Seung Jang. I'm working at the Seoul National University, Technology and Science.
We have 3 different presentations in this track. And the first presentation will be on advanced occupancy for super tall buildings and the concerns and responsibilities that need to be addressed on that matter. I'd like to introduce the speakers for this first presentation. Peter Weismantle is Director of Supertall Building Technology at Adrian Smith and Gordon Gill Architecture, located in Chicago. He previously served as Senior Technical Architect on several Supertall towers, such as Jin Mao Tower in Shanghai and Burj Khalifa in Dubai, United Arab Emirates. And he's currently has several Supertall projects that he's involved with, including the Greenland Center Tower in Wuhan, China, and the Kingdom Tower in Jeddah, Saudi Arabia. And speaking with him is Mehdi Jalayerian. He's Executive Vice President and Managing Principal for Environmental Systems Design in Chicago, USA. He has extensive experience in HVAC and sustainable design practices. He's Chairman of the Energy and Sustainability Task Force for the Chicago Committee on High-Rise Buildings. And he also serves as adjunct professor at the Illinois Institute of Technology in Chicago in their Department of Architecture. Please welcome Peter and Mehdi.
Thank you very much. I'm Peter Weismantle. This is Mehdi Jalayerian. And we're very pleased to be here to speak on a very important subject. It's important because of the whole issue of sustainability. Sustainability also includes an economic aspect, and as we build taller and taller buildings, they do take longer and longer to build. And so the idea of advanced occupancy, which is sometimes called phased occupancy, is a concept that was pioneered, and I'll say this being a Chicago chauvinist, pioneered in Chicago. I actually don't know if that's true. But it has been pioneered on several projects in Chicago, and simply put, it allows for the beneficial use and occupation of completed portions of large projects, well in advance of completion of the overall project. And so that's really what we're gonna talk about today. Hopefully, let's see. There we go, I guess. So what is it? The ability to occupy completed parts of a building before the entire project is completed. And why is it important? It's important, especially in high-rise buildings, thank you very much, because it provides an early source of revenue, and it improves the economic feasibility of these projects, which we all think is important. Without the economics, we're not going to build these projects. And how is it done? And I think that's really what we're going to concentrate on. And it's really done by means of a structured, comprehensive, and logical program to provide for the health, safety, and welfare of all the parties that are involved in the building. And it's not only, it's the occupants, it's the people that manage the building, it's the contractors, because as Ahmed pointed out in his earlier presentation, the building is probably a building like that is under construction is probably as alive as it ever will be. There'll be more people in that building doing more and different things at that point of time than in any other time of its after post-completion days. It also involves a great deal of cooperation with the local authorities, including the firefighting, the public, and police. Whoops. Okay, a couple of examples of projects in Chicago that brought advanced occupancy to the forefront are projects that Mehdi worked on, starting with 900 North Michigan. And the project that we're going to talk about today is a project that we both worked on called Trump Tower, which is currently the second tallest building in Chicago, third tallest building in the US, something like that. But I don't know why I can't. Oh, I'm sorry. Technology. I think the important thing about advanced occupancy is that it brings the whole team together. And one of the reasons we're kind of speaking as a team is kind of to exemplify that. It's not only the design team that gets involved. It's the local authorities, the building department, fire brigade, police. And it requires, from the start of the project, a very integrated design, construction, and ownership approach. All of those parties have to initiate that before you can even hope to get the cooperation of the local authorities. And so once the approach is actually kind of conceived, it is administered by the local building authority, but it's run by the owner, and that's an important point as we go through this. The point of doing the way of doing it successfully is to make sure that there's no more onerous requirements on anyone other than the design and construction team. In other words, keep it simple for the city, keep it simple for the authorities. And of course, it always goes back to requiring compliance with the local practices. Okay, there we go. I can see our technology is a little challenged here. Is this? No? Okay, anyway. Now, the important thing to start with is you have to develop a process. You have to have a very, very simple process. And to develop the program, you have to take into account the unique architectural aspects of the building. And the unique aspects of a super tall building include the vertical transportation system, which is of utmost importance. Active fire protection systems, passive fire protection systems, taking into account construction logistics. Because remember, while parts of the building are occupied, the rest of the building is being constructed. Building management operations comes in the managing and maintenance of those systems. And then, of course, once you develop your program, you need to obtain the review and approval of the local authorities, and then obviously successfully administer it. I'm sorry. Okay. Oh, I see. Architectural design considerations. Well, I said right from the start of a project, you have to take into account the fact that it might be partially occupied as you go up the building. Obviously, you're going to be occupying it from the bottom to the top in general. And so the most important aspect from an architect's standpoint is the logical and sequential organization of the programmatic stack. And by that we mean in the buildings that we're going to talk about, especially Trump, it exemplifies what's called a mixed-use project, and with several different types of occupancy, separated generally by mechanical rooms or structural outriggers or breaks in the program that allow for partial occupancy of the tower. And it's important to keep in mind that there will be certain front of house activities and back of house activities that all have to function properly, both from the public standpoint, from the management standpoint, and also from the local authorities standpoint. So we're going to start with some of the design considerations in Trump Tower, which was completed, formally completed in June of 2009. However, the partial occupancy actually started in about October of 2007 with what was called phase one. No, I guess I'm at phase two here. Let's go to phase one. Phase one, which included the garage areas and the hotel amenity areas. Oh, a little bit of an overview, if I can. The building itself is about 92 stories tall. It has a garage, hotel, which includes hotel amenities. It's kind of a hotel condo-tel kind of arrangement, but let's call it a hotel. And then there are 3 groups of apartments in the tower above to complete the 92 stories. it has an interesting location because it's located on the Chicago River, and right adjacent to it was a viaduct that actually had to be rebuilt, and that's the area to the left in the kind of beige color. So what you're seeing on the screen now is a plan of the base of the building. Okay, let's see if I can do this. Okay, here's the tower in plan. Here's the core, and here are the surrounding streets. And so phase one, which included, as I said, the occupation of the garage and some of the hotel amenities up to about level 16, I think it was affected in about October of 2007. Construction started, I want to say, in September of 2004 or so. So this was in fairly short order. The important thing about any phase of advanced occupancy is that the building, the public parts of the building, the occupied parts of the building, should function seamlessly. Now, we have in the tower itself, there's a fireman's elevator that actually connects all the floors of the building, but obviously at this early stage, the top of the building wasn't even there. So there wasn't a machine room for that elevator. So the fireman's elevator was identified using one of the low-rise elevators with a protected lobby that still allowed for fireman's access. The logistics of construction is a whole nother story. I mean, that could be a story in itself, because as the building was occupied, there was this dance, if you will, around the base of the tower that allowed for logistics of material, bringing materials in. In the case of Trump, we actually had, because of this viaduct situation, we were actually able to use some top and bottom levels, if you will, adjacent to the tower to bring materials in and obviously rubbish out and things like that. But at this very first phase, as I said, it was just really a parking garage. Okay, it should, this, no. I'll use the roller. Phase two, whoops. Phase two then included the hotel portion. And this was, the goal was to get this open, I think, at Christmas of 2007. I think it actually made it at Christmas of 2008. Not Christmas, I'm sorry, January of 2008. Again, the sequence, what was active and what wasn't active is shown on the core. The service elevators doubled as firemen's elevators. The logistics, there was still a hoist, and we'll show you some photographs of construction. And again, important thing, again, remember the rest of the building is not there. So from a life safety standpoint, it means that they're still doing picks. They're hoisting. They're actually constructing the slabs at that level over basically a active building. So a crash deck was built in to protect the public, getting to the building through the lobbies, et cetera. Phase three and four and five really were done over a period of about a year. From June of 2008 until June of 2009, the residential portions were opened in 3 phases. And of course, it was only at that last phase that all of the vertical transportation elements were in place, so that the fireman's elevator finally became the permanent fireman's elevator. All the stairs were active. Not that they weren't active before, but there no longer needed to be buffers between the areas under construction and the areas that were occupied. I think I'd like to talk a little bit about the logistics of the site. Do you want to take over at this point? Then I'll give you this.
The site logistics was very important, not only for the project itself, but also for the city officials and firefighters. So this diagram here indicates all the fire hydrants that are nearby at the lower level of the project that had to be identified and clearly understood by not only the design team, but also the contractors and operators during the construction phase to make sure that all those are accessible and they're achievable to use during the construction process. One thing also notice, this project had a 2-level, lower level and upper level. There was a viaduct here that needed to be constructed during the construction. So there was a portion of the roadway that was also blocked off that had to be not only planned for, but also discussed with the city officials to make sure that the planning can be taking place and awareness is there during the emergencies and any conditions that may arise. From the system standpoint, as Peter indicated earlier, the same concept was followed throughout for all the active systems. In this case, active fire protection system had to be zoned in accordance with the occupancy and had to be planned so a portion of it, as the phases were built up, they could be tested and monitored and operated for that particular phase, and independent from the rest of the building. As the building was constructed further, those new systems would come online and integrated with the prior construction, and again had to be tested again for that phase to make sure that the system operates properly. We talked about 5 phases of the project. These diagrams here indicate how the building was built up. The project essentially had 2 water supply systems for the project, and had a combined sprinkler and standpipe. We ended up with 3 vertical pumping systems, one at the main, which was really the city pressure through the main pumping system, and then 2 water storage tank levels to accommodate the rest of the building requirement. On the electrical side, the same configuration had to be considered here. This building has a high voltage riser, which was looped system. As you can see here on this diagram, the main incoming service were from 2 different directions to the main, these green lines, and then built up to the first zone as a loop, and then extended to each one of these zones independently. So you basically had a small city vertically built that could be operated and used independent from the rest of it. Again, we talked about expandability and a configuration of the system that adapts itself to construction process and coordinated with that configuration. On the emergency side, emergency power was, again, powered the same configuration as the rest of the systems. We had a low voltage generators that were at the base, and they were located directly below the ramp, because the ramp for the parking garage was supposed to be built first. That part of the construction was done, and it was away from the rest of the logistic, the material movement, so the emergency generators were operational during the first phase, and they could feed the lower zone and then expand up independently from one another from the load centers up and down to serve each occupancy areas. Let's see, emergency power. Fire life safety was very essential component of the project. It had to be tested not only by the operations for the building, but also needed to be monitored by Chicago Fire Department to accommodate any emergencies that need to be attended to. The command center was located at the lobby level, and that had to be built and constructed initially and expanded during each one of these phases to accommodate the new areas of the buildings that are coming online for occupancy. So it was essential to zone the system appropriately so it can be constructed, run, tested, and monitored independent from the rest of it, and have a very short downtime between the time when you switch to new occupancies. As you know, fire and life safety systems require dedicated monitoring and integrated with the building operation and security. Similarly, HVAC system, again, had to be zoned in accordance with the occupancy. This first phase was the parking. You can see here, these are actually floor-by-floor systems. They were very independent from the rest of it with the lobby and amenities. And then as you go up to upper levels, those become more central located to feed down or up, depending on what the zone was, and follow the same concept as the rest of the system. These are some of the diagrams for material handling for construction. Again, these had to be planned and defined and reviewed by the building department and fire department to make sure that everybody's on board and everybody understands what the process is, and if there's a case of emergency, they would be able to access the project. So you can see here the material for the project was routed to come back and come actually on the river side and go out. So the frontage of the building for access for fire trucks and those would be left alone and left open for all the operations. The hoist was on the riverside for material hoist. You can see here on the construction photo how it was planned. And also there was a staging area here and also on the upper levels. This diagram shows the radius for the coverage for the crane. The material hoisting was located here at this zone and also this area. This coincided with the roadway that was being built here, so they could easily fence that out and logistically operate that. You'll see this ramp that was built here, but the crane covered that, so there's a protection that had to be provided there for the people to get into the occupancy of the building. This is a diagram of the first phase. You can see what part of the building is operational. Parking, essentially, you can actually see here has a sign, parking is open. This was the first phase. There was still a crane at the top of the building. On the rest of the process, you can see the diagrams for the... Okay, thank you. These are, again, some of the diagrams for the overall construction that are coordinated with the achievement of the hoisting and everything else. Hoists are removed here, cranes. You can see the area for the hoisting that was identified to accommodate for the material to the upper levels of the building.
Yeah. What you're going to see now is just a 2-minute video that was prepared for a competition that we were successfully completed in Jeddah, Saudi Arabia. And it shows the concept of advanced occupancy not only brought to a particular project, but also to a district. The competition was for the next world's tallest building, and surrounding it were 5 properties that were also part of the original design. And so we established, with some work on logistics, a way of organizing the site in a way that portions of it can be completed in plan, as well as organizing the building so that portions of it could be completed in section. So it was kind of a 3-dimensional advanced occupancy, so that not only, as you can see, not only can portions of the tower be completed, but the surrounding towers could be completed within a certain amount of time. So 3 years, 6 months from the start, we actually would have completed a hotel and service apartments adjacent to the tower, amenities concourse, and have completed and occupied the up to about level 20, about level 46 in the tower itself. Meanwhile, the tower is continuing construction. Of course, as it gets higher and it gets smaller, it goes more completely. But still, occupancy at 4 years, 9 months would have been up to the top of basically residential group 3, which is about at level 103. And then by the time the total building was completed and everything occupied, about 5 years, 6 months, the surroundings, meantime, the surrounding buildings, which are much smaller and much simpler, would have been bringing revenue in for over 1.5 years. Making the economic viability of the project a lot more attractive. You don't have to wait 6 years or 5.5 years to get any income back on your investment. And that's what this diagram kind of basically shows. Conventionally, you would be spending a lot of money, and that's the blue line below the line. That's how much money the owner is investing in the project, only to start to get revenue there in the red at the end. By moving that up, by starting to occupy phases of the work or parts of the project, you can bring that revenue to an earlier stage. And these are, I think, 3-month increments. And this is more or less what shows what happened on Trump, where the garage revenue then is followed by the hotel revenue, then is followed by the 3 groups of residential revenue. So you can see, take the red and the green, you combine it together, you certainly are reducing the carrying costs of what can be a very high price. So I think that's it. So thank you very much for your time and patience with the projector and me and Mehdi, and thank you.
Thank you.
Thank you for your project presentation on your time. Actually, even you have technical problem at the beginning of the presentation. Sorry for the inconvenience. If anyone has a question about this presentation, please raise your hand. Then the assistant will deliver the microphone. Anyone? Yeah, he has a question.
Yes, my name is Peter de Jong. I'm very much interested in the cost part, so thank you for leaving this slide in front. Oh, there it's gone again.
I didn't do it.
The additional revenues are impressive, but can you give also a ratio about the additional costs for the advanced occupancy?
Well, that's a good question. And it wasn't so much in material costs, it was maybe in management costs, but I think Trump will say it didn't really cost anything. It was just, we just put the process in a way that allowed the natural, again, you go back to the very start. If you organize the building in a certain way, and these tall buildings almost are, Trump is like 3 or 4 30-story buildings, stacked one on another. So they really are designed so that they can be run autonomously. And so it really was taking that kind of happy circumstance and then being able to take advantage of it by running it autonomously, running that lower section, the hotel section autonomously, and then running the lowest, at least the lowest range of apartments autonomously.
I think the revenues that were generated from the early occupancy by far exceeded what the incremental cost of the operation would be. Obviously, you have to mobilize your building operations early, but you also have a revenue that goes against that. So it really, from a cost of construction, it really didn't change anything. It actually made it simpler because we thought about it and organized the systems in a way that they can run, test them, and operate them, and then add to it as they go along. They had to do that at the end of the project anyway. This actually simplifies it because you're doing them in smaller increments over the life of it, the construction.
Okay, if there's one more question, otherwise we're going to move on. One more question? Okay, all the speakers will be available afterwards, and you can catch them during lunch or